Now let us see the second chapter of Math second is Pythagoras Theorem. What is Pythagoras Theorem? In right angle triangle, square of the hypotenuse is equal to the sum of the square of remaining two sides. This is a Pythagoras theorem. Now in right angle triangle, now let us draw first right angle triangle. Suppose this is a right angle triangle ABC, where angle B is a 90 degree. Then which is the hypotenuse here? The opposite side of 90 degree is called the hypotenuse. That is AC is the hypotenuse. Then what is theorem in right angle triangle? Hypotenuse square is equal to, hypotenuse is AC. AC square is equal to the sum of square of remaining two sides. Which are the remaining two sides? AB and BC are remaining two sides, and sum of this square, that is AB square plus BC square. This is what the Pythagoras theorem. Now let us see Pythagoras triplets or Pythagorean triplets. Now there are three sides of a triangle. Suppose 7, 24 and 25 are the three sides of a triangle. Now square of the one side, square of the greater side. Which is the greatest side here? 25 is the greatest side. The square of the greatest side, 25 square, is 625, is equal to the sum of the square of remaining two sides. That is 7 square plus 24 square. What is the square of 7? It is 49, and square of 24 is 576, and sum is 625. That is square of the greatest side is equal to sum of the square of remaining two sides. Then these three numbers are called the Pythagoras triplets. That is 7, 24, 25 is the Pythagorean triplets here. Let us see another example. Suppose 7, 8, 9. These are three numbers. Which is the greatest side here? 9. 9 square is equal to 81. And square of sum of the square of remaining two sides, that is 7 square plus 8 square. It is 49 plus 64, and sum is 130. Now these two are not same. It not is equal to 7 square plus 8 square, that is 81 is not is equal to 130, 13, and therefore 7, 8, 9 is not a Pythagorean triplet. That means these are not sides of the right angle triangle. 7, 24 and 25 are the sides of right angle triangle. Here 7, 8 and 9 are not the side of right angle triangle. Now let us see property of 30 degree, 60 degree, 90 degree triangle. Now let us draw the triangle of 30, 60, 90 degree triangle. Suppose this is a triangle PQR of 30 degree, 60 degree and 90 degree angles. Now what is the property of 30, 60 and 90 degree triangle? In 30 degree, 60 degree, 90 degree triangle, opposite side of 30 degree is half of the hypotenuse, and opposite side of the 60 degree is root 3 upon 2 times the hypotenuse. That is, which is the opposite side of 30 degree? Here opposite side of 30 degree angle is PQ. This is the opposite side of 30 degree PQ, which is half of the hypotenuse. Which is hypotenuse here? PR is the hypotenuse. It is half of PR. And opposite side of the 60 degree. Opposite side of 60 degree. That is 60. Which is the opposite side of 60 degree? QR. QR is equal to root 3 upon 2 times. Root 3 upon 2 times the hypotenuse. PR is the hypotenuse. This is what the property of 30 degree, 60 degree, 90 degree triangle. Now let us see one example on this property. Suppose we have given that here this is a angle 30 degree, this is a 90 degree, and this is a 60 degree. This side is a 12. This is a triangle X, Y, Z, and we have to find X, Y, and Y, Z here. We have given that in 30, 60, 90 degree triangle X, Y, Z, hypotenuse is 12, and we have to find X, Y, and Y, Z. Now, which is the opposite side of 30 degree first? Here, opposite side of 30 degree, it is YZ is equal to, is half of the hypotenuse. Half of the hypotenuse is XZ, that is half of XZ we have given that 12, and therefore it is a 6. Now let us find other side, opposite side of 60 degree. Which is the opposite side of 60 degree? XY. XY is equal to, it is root 3 upon 2 times the hypotenuse XZ, that is root 3 upon 2, and hypotenuse is 12, and therefore this is 6 root 3. XY is equal to 6 root 3 and YZ is equal to 6. Now let us see the second property. Property of 45 degree, 45 degree, 90 degree triangle. Now let us draw first this triangle. Suppose this is a triangle ABC, which is of 45 degree, 45 degree, 90 degree triangle. Now what is the theorem? Opposite side of 45 degree is 1 upon root 2 times the hypotenuse. That is, which is opposite side of 40 degree. Now here two sides, AB and BC. This is also opposite side of this 45 degree, and this is opposite side of this 45 degree. And we have seen previous standard, that is isosceles triangle theorem. Opposite side of equal angle are equal. Therefore, AB is equal to BC is equal to 1 upon root 2 times the hypotenuse AC. AB is equal to BC is equal to 1 upon root 2 times the AC. Now let us see one example here. Suppose we have given that this hypotenuse is root 8 and this is a triangle PQR. We have to find PQ and QR here. And this is a 45 degree. This is also 45 degree. Now by property of 45, 45, 90 degree triangle, PQ is equal to QR is equal to. Now this is also opposite side, and this is opposite side of 45 degree, that is 1 upon root 2 into hypotenuse is PR, that is equal to 1 upon root 2 and hypotenuse is root 8. These two numbers are in the root, therefore we divide directly. It is root 4. Bechok at root 4 and square root of 4 is 2. Therefore PQ is equal to QR is equal to 2. Now let us see second example here. This is a 45, 45, 90 degree triangle DEF. We have given that DF is equal to 10 and we have to find DE and EF. Now by property of 45, 45, 90 degree triangle, which is opposite side of 45 degree? DE, and second side is EF. DE and EF are opposite side, and which is 1 upon root 2 times the hypotenuse DF. DF is a hypotenuse. Now let us put the values 1 upon root 2 into 10. Now how this divides make 1 upon root 2 and 10 can be written as 5 into 2 and 5 into root 2 because we have to cancel this root 2, that is 5 into root 2 into root 2. That's 1 root 2 get cancelled and it is 5 root 2. That is this DE and EF are 5 root 2.